All right, so this is chapter 2, lesson 2.10. We're changing, or it's change expressed as a percent. Go ahead and put your name on that first page, and let's get started. Okay, so to find percent change, that's our objective, and we also are going to find the relative error in linear and nonlinear measurements. Put a star next to that second one. This will not be on our exam. Okay. All right, percent change. So percent change is the ratio of the amount of change compared to the original amount. And what that means is the amount of change that's happening, you're not just calculating the amount of change, you're also comparing it to the original. So you're dividing by what it began with, or the old amount. The percent increase, so that's if the change is positive. So if you increase and then you compare it to the original, then that would be percent increase. Or if you decrease and then you compare it to the original, that would be percent decrease. Okay, so what we're going to use for percent change to calculate it is called the no equation. That's n minus o over o, where n is the new and o is the old. Okay, that could be a new price versus an old price. That could be a new number versus an old number in terms of amounts. It could be several things. Okay, if the result is positive, it's percent increase. And if the result is negative, it's percent decrease. So let's take a look. A coat is on sale. The original price of the coat is $82. The sales price is $74.50. What is the discount expressed as percent change? So if the original price was $82, that's considered the old price. So we're going to put an O above it. And then if the sales price is $74.50, that's considered the new price. So we're going to put an N. And all we're going to use is the N minus O over O. We knew to use that because it asks for percent change. Whenever you see percent change, think of that no equation. Okay? N-O-O. New minus old divided by old. This is going to turn into $74.50 minus 82, all divided by 82. So 74.50 minus 82 give us negative 7.5 in the numerator divided by 82. Oops, if we divide by 82, we should get negative 0.091. Okay? Now, it is negative, so we know it's going to be percent decrease. Okay, but we do have to change this into a percentage. So we're going to move the decimal over 2 spaces. So it's actually going to be negative 9.1%. So it is a 9.1% decrease. Remember, when you are moving it from here to writing it as percent decrease, you don't write that it's a negative 9.1% decrease. You just write 9.1% decrease. The decrease means that it's negative, okay? All right, finding a percent decrease, let's try another problem. So the average monthly precipitation in Chicago, Illinois, peaks in June at 41 inches. The average monthly precipitation in December is 2.8 inches. What is the percent decrease from June to December? So in this case, it's asking for percent decrease. So we know that our answer should be negative. If it's not negative, then we did something wrong, okay? So in June, it's 4.1 inches. That's going to be our old value. Why? Because June is before December. And December, it's 2.8, so that's going to be our new value, okay? So we're going to take 2.8, subtract the 4.1, divide by 4.1, and at this point, I can already see that we set it up correctly. How? Because 2.8 minus 4.1, that's going to give us a negative number. So we already know that it's percent decrease, so we're good to go. So let's take that 2.8 minus 4.1. We're going to get negative 1.3 on the top. And that's going to be over 4.1 in the denominator. And if we actually do that division, negative 1.3 divided by 4.1. Oops. Negative 1.3 divided by 4.1. There we go. It is negative 0.317. And this written as a percentage will be negative 31.7%. Remember, you just move that decimal place over 2 spaces. And so we have a 31.7% decrease. All right. Finding a percent increase. So in this case, we're going to do the same thing. Okay, we're going to label our new and our old values, and then we're going to set up our equation. So a store buys an electric guitar for $295. The store then marks up the price of the guitar to $340. What is the markup expressed as a percent change? Percent change. So remember, percent change, we should automatically think n minus o over o, where our n, which is our new value, so that's the markup value, that's going to be $340, and our old value, or the original price, was $295. So let's do 340 minus 295 divided by 295. And at this point, we can already check, because since our old value is less than our new value, okay, then it's percent increase. And we know that it's and we know that because our value is going to be positive. Okay, so let's see. So 340 minus 295 is 45 over 295. So we're going to divide by 295. That will give us 0.153 if we round. And this is the same as 15.3%. So therefore, it's a 15.3% increase. Okay? We knew it was increased because this is a positive value, 15.3. Okay, moving on. All right, we're moving on to relative error. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value, okay? So relative error equals the absolute value of the measured or estimated value minus the actual value over actual value. It looks very much so. So right, similar to the no formula, okay? But our new is now our measured, and our actual is now our old. If you want to put a star, this is the information that will not be on your test. Will not be on test. Okay, so your test will include the previous slides involving percent change. For these, you just need to know them for the homework. Okay, so finding percent error. Okay, that's relative error. So a decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? So 5 by 8 is our estimated. And the actual area of 5 by 8 is 40 feet squared, or 40 square feet. Oops, write that again. 40 square feet. Now, the actual area was 4 by 8 feet, so that's going to be 32 feet squared, and that's the actual. Okay? And it wants us to find percent error, so we're going to use that same formula. So our measured or our estimated was 40, so let's write relative error equals, and we're going to write 40, the absolute value, 40 minus 32 divided by 32. Okay, now for relative error problems for the homework, all I'm going to ask you is to set it up correctly. Okay, I'm not going to ask you guys to actually solve them. Okay, so this would be sufficient for the relative error problem. All right, if you were to solve this, you should just do 40 minus 32, which is 8, divide by 32, and you should get 0.25, which is 25% error. So he was 25% off the actual area of the rug. Okay, finding percent error. So you think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.75 miles. What is the percent error in your estimation? So remember, percent error is the same as relative error, and we have to find out what's the actual and what's the estimated. Our actual, so that's going to be A, is 4.75 miles, and our estimated, because it says you think that the distance between your house and a friend's house is 5.5 miles, that is our estimated. Okay, so what we do is we take the estimated inside the absolute value, so 5.5 minus 4.75, which is the actual, and then we divide by the actual again, which is 4.75, okay? From here, we're going to get 5.5 minus 4.75. We get 0.75 divided by 4.75. And we are left with 0.158 roughly, which is 15.8% error. Okay, finding minimum and maximum dimensions. Okay, we are skipping this, and we're also skipping the next slide. Okay, that's applying relative error. I don't need you guys to know that. Okay, now we're going to check ourselves before we wreck ourselves. Running, so last year an athlete's average time to run a mile was 6 minutes and 13 seconds. This year the athlete's average time is 6 minutes and 5 seconds. What is the percent decrease? For these three problems, again, don't do number 3. For number 1 and 2, I want you to try them on your own and then check your answers on the next. But we'll go over these together. So 6 minutes and 13 seconds, you have to convert that into fully seconds. Same with 6 minutes and 5 seconds. Okay, so it says last year, so that's going to be our old value. And then this year, that's going to be our new one. Okay, so 6 minutes and 13 seconds is going to be 6 minutes. We're going to change that by multiplying by a conversion factor. Remember, we want to change it into seconds, and we have minutes, so we want to cancel the minutes out by putting in the denominator. 1 minute is the same as 60 seconds, so we just take 6 times 60. These minutes will cancel, and we're going to be left with seconds. 6 times 60 is 360 seconds. Okay, but remember, we still have to add back the 13 seconds. So this becomes 376 seconds. Let's do the same thing for 6 minutes and 5 seconds. Remember, this 6 minutes, you have to multiply by 60 seconds over 1 minute. The minutes are going to cancel, and we're going to get 360 seconds plus 5 seconds. Don't forget about the 5 seconds up here. Okay, and we get 365 seconds. So this is our old, this is our new. So all we have to do is apply our formula now. So that's going to be n minus o over o, which is going to be 365 minus 376 over 376. 365 minus 376 is negative 11 over 376. Divide by 376, and we get negative 0.029. And if we move that decimal over 2 spaces, we're going to get negative 2.9%. which is the same as a 2.9% decrease. And we can always check our answers by going, okay? Next one. Okay, so a used car dealership buys a car for $2,800. and then sells it for 4,500. What is the percent increase? So we know our answer has to be positive, okay? So if they bought it for 2,800, that's our old price, and then they're selling it for that, so that's going to be our new price, okay? So all we have to do is set up the same equation. Let's put number 2 down here. So n minus O over O. So n is going to be 4,500 minus 2,800 divided by 2,800. And guys, we know this is correct. Why? Because we are going to get a positive value, right? 4,500 minus 2,800 will give us a positive amount. And we're looking for percent increase, so that is awesome. 4,500 minus 2,800, 1,700 over 2,800. That's a large increase at 0.607% increase, which is the same as 60.7% increase. We got that one right too, okay? So if you are getting these, awesome. It's only a matter of applying the NOO formula, the no formula, okay? New minus old divided by the old. Slide, okay, to the next page, and it's about 2%. That's perfect. So that one we got right. About 61%. Oops. Okay. Reasoning. So this is our exit ticket. What is the greatest possible error of a measurement taken to the nearest tenth of a meter? Okay. So let's think about that. Remember, our estimated is going to be subtracted from the actual. And if our measurement is 0.1, but the actual is, say, 0.9, what's the greatest possible error of a measurement taken to the nearest tenth of a meter? Okay? So let's take 0.9 minus 0.1 over 0.1. Want the greatest difference, right? So let's say we were off by that much. So let's take 0.9 minus 0.1, which is 0.8. And if you divide by 0.1, you get 8. So 800%. You can have an 800% error. Okay? So still a lot of error, even if it's the nearest tenth of a meter. Okay? Here's your homework. Good luck.